AICTE Training and Learning, a TEL Academy with a vision to equip faculty members and researchers across India with the tools, knowledge, and future-ready perspectives required for today's and tomorrow's computing paradigms. We are truly honored to have among us a galaxy of distinguished personalities who are pioneers in their domains and torch-bearers of innovation in this field.
Let me take a moment to acknowledge and welcome our chief guest, Professor Dr. Yudhvir Singh, Director UIET Maharishi Dhyan University, Dr. Vikram Goyal, Professor IIIT Delhi, Professor Lalit Agrawal, Vice President MERI, Professor Preet Singh, Principal MERI PLI, Professor Umesh Gupta, Director MERI CET, Dr. Manju Singh, Registrar MERI CET. We also welcome faculty members, researchers, and enthusiastic participants from the institutions.
MERI Group of Institutions is a part of higher and technical education promoted by a non-profit organization named Triveni Education and Social Welfare Society, established under 1987. This society runs various institutions to provide quality education from kindergarten level to postgraduate level, primarily in professional courses. The society manages institutions like Ramakrishna Senior Secondary School, Ramakrishna Teachers Training Institute, Management Education and Research Institute, and MERI Professional and Law Institute.
We have 30 international collaboration with universities all around the world, running from Korea and China in the east to France and Germany. Ma'am, Manju ma'am, please join.
To this 5-day Atal-sponsored faculty development program. I welcome Professor Lalit Agrawal, sir, Vice President, MERI Group of Institutions, who has spared his valuable time despite of his very busy schedule these days. I welcome Professor Yudhvir Singh, Director, University Institute of Engineering and Technology, MDU Rohtak, for sparing his valuable time and coming here to guide the participants and motivate. His presence is always a motivating force for us. He is always ready to help our institute in all the respects, all the functions, and all the events we are doing in the last 5 years. We also welcome Professor Vikram Goyal, Professor at Computer Science Engineering Department at IIIT Delhi, for sparing his time, and Professor Preet Singh, and all the participants from various reputed universities and to the various nearby institutes. And also to my students, dear students. So I welcome you all to this 5-day faculty development program, and I wish this event will enrich your knowledge and gain some practical exposure to the supercomputing and the quantum computing field. Thank you so much.
Thank you so much, sir, for your valuable thoughts. Now I humbly invite our esteemed Vice President, Professor Lalit Agrawal, sir, to address the gathering and share his valuable thoughts with.
Good morning, everyone. Dear Professor Yudhvir Singh ji, Professor Goyal, Professor Preet Singh ji, and Umesh. Thank you first for coming here and giving our faculty members and the faculty from all other institutions a motivation for this topic, which is a current topic and a very, very important topic. When we talk about supercomputing and quantum computers and computing, the world is moving very fast towards this direction, especially with the advent of artificial intelligence and machine learning systems. We need to have high-speed facilities which can do work because the data which is being generated needs a very, very high-speed machine which can process the data, which can help us in calculating or mitigating various and complex problems we are facing all around the world. The world is changing very fast, especially these days when we have seen that a lot of turmoil and challenges are happening all around the world. Any institution, any individual, any country can grow only and only if it has a technological edge over the others. To that effect, our researchers here, our professors here need to train themselves in the new cutting edge technology. Indians all around the world have been doing exceedingly well in the field of information technology. We have heads of Google or Microsoft and many other big IT companies who are Indians. But at the same time, we back here in India lack that edge if we see the global scenario. This initiative and support by AICTE in helping us organizing this program on helping us and organizing this program on supercomputing and quantum computing is a need of the hour, and we really thank them. Professor Yudhvir Singh and Professor Goyal are here. They would be guiding you much deep into the processes, the challenges, and the opportunities available for the faculty members to grow in this area and develop in this area. And also to take this knowledge back to the students so that they can perform well once they pass out of the institutions. And we as a country are ahead in these areas like any other country, especially when we see the West. We know that we have the potential, and we know that initiatives like these are going to help us all. I thank Mr. Yudhvir Singh, Professor Yudhvir Singh and Professor Goyal for coming here, and they will be guiding you and motivating you for this important topic. And I hope that by the end of these 6 days faculty development program, we will have good insight into these areas, and we all will be working strongly in these areas and taking this knowledge to our students.
Now, I would like to invite Sir to please come on the stage and guide us. A big round of applause for Sir. Sir, please come.
Respected Professor Lalit Agarwal ji, Professor Vikram Goyal ji, Professor Preet Singh ji, Dr. Umesh Gupta ji, my dear fellow colleagues, good morning to all of you. First of all, I would like to thank the college to invite me as a chief guest on this function. Today, as in this, I will not go into the technical detail, just giving the brief about this particular program. This is one of the good initiative is done by the college as a faculty development program, and the college have taken the theme of this FDP is very good in nature. As we know, this is era of Industry 4.0, which is led to that is basically run by the AI data science. But can AI data science work with the computing machines? No. And here the quantum computing is just to exploit the power of exponential. If we are saying that 2 plus 2 is equal to 4, 3 plus 3 equal to 6, but if we say that 3 raised to power 3, that will be raised to 81. Just the very small numbers, addition is 9 and their exponential is 81. So this is basically the fundamental behind the quantum computing. And basically one quantum, as we know, the word quantum is using the qubit, and this is containing the 4 states instead of the binary bits. So this is the basically the 2 to 4 with the superposition and entanglement of the skewness of the. So this is the basic fundamental in the quantum computing, which is the basically the concept of the physics and the atomic position, but that is used in the computing, and that will be lead to the exponential rise in the computing. And now we are seeing that data will be rising very sharply. If we say that, if somebody said that 40 years earlier, how many data will be used by some person, and you say that if that will be the question is asked 40, 50 years, what is the data which is used by the person? And that is, nobody know internet, nobody know later on technology which we are using. So as the technology grow, so the data will be increasing later on. If we recall the Indian history of the telecommunication, 2003, Reliance came into the market, Reliance phone, and that time the first time becoming the free incoming on the mobile phone, and that will be the reach of the mobile phone to the general public, and that will be the huge change in the market scenario in the telecommunication. And that is the first step. When every person will be getting some connectivity, the second step we recall the came of the geo, free data, and that will become the habitual, and everybody is using that. Now we are paying enough for that. If we compare that even with the other countries, even that is a very smaller as compared to the other country, that amount is. So this is the change into the scenario where we are using the data and data. For the data, if we have to search something on the Google, where data came? Data came with our computing machines. And can a simple computer can do that? No. So that the concept of the high power computing is came into the picture. And when many years earlier, when India needs some computing machine, then US is refused to give the computing machine. So that time the CDEC is coming into the picture, and that will be take a leading step for the country, and they have developed the PERM supercomputer. I think we have heard the name of that. And when that is developed, that is one of the powerful supercomputer as compared to the available supercomputer in the world. And now we have the various version of the PERM still exist. They are still very good configuration as compared to the other supercomputers. So because of that particular type of the initiative taken by the country, the mathematical foundation is good, and we are the leading into the IT sector. If any of the world, any part of the world, if somebody we need a IT professional, first thing is coming into look to the India. If they know we have to search for the electronics engineer, VLSI engineer, they are not coming to the India. They are going to the Taiwan, China, Korea. If we need the best mechanical engineering in the world, so they are the first of looking for the Germany. So this type of the step have taken done by the Indian industry. And as we know, this particular era is not the war of the persons or the countries. Now this is war of the technology, war of the company. Now we are hearing some few names in the industry: Elon Musk, Mark Zuckerberg, and Google. There are so many companies. They are not the simple company. They are moving the policies of the country. They are moving the international policies. And now we have seen the few war in just the Ukraine-Russia war, Israel, Iran, and Israel, Hamas, and very small patch of the India, Pakistan. So what is happening behind that? Is the person or the fighting on the border? Rarely. But this is war of the technology. So whosoever is the ahead in the technology, that will be lead in the its position at the every level, at level of the individual, at the level of the organization, at the level of the country. So this type of the step taken by the college to upgrade the faculty of the not only the college itself and but by the some sounding college is a very good step has taken by the college, and so we have to get we have to take the maximum advantage of this step. Otherwise, we are the coming here for the 6 days, and this 6 day will be passed on. But if we utilize that in a fully way, then that will be the benefit for our future also. So I wish all the participants to take the participant in this particular FDP seriously, and I hope they will be learn something and they will be the take something with them. And thank you. Jai Hind, Jai Bharat.
Okay, so thanks for inviting me here. Professor Lalit, Professor Yudhvir, Professor Preet, Professor Umesh Gupta. So thanks for inviting me, and I normally actually like to visit specifically colleges in Haryana. So, because the reason is I actually belong to Haryana, and I did my basically BTech from West College of Engineering Rohtak, and then went to Delhi for my master and higher education. So the topic that was given to me, like when I discussed with Yudhvir, was supercomputing and supercomputers, right? So first of all, a fact, I don't work in supercomputing area. My area of research is data science, big data and AI. But of course for this talk, like I need to prepare, and it gave me a good opportunity to prepare and find out good facts which I should share with you guys, right? So first of all, how did we get first supercomputer in India? So how many of you know about that? First supercomputer that actually India had. So you should, yeah, you raise your hand. Param Sampuku, but how did we get it? So the reason for having our first supercomputer in India is that USA denied us access to the supercomputer. In 1987, we were actually asking them to give us a supercomputer named was Cray XP, right? And they denied us, telling us that if we use this supercomputer, if they give us this supercomputer, we are going to use it for nuclear warfare and all that, right? And citing that as a reason, they denied us. And that was the initiation of India working on supercomputing technology. And will you believe, within 4 years, we had our first supercomputer, and that supercomputer actually was Param 8000, right? And the speed of that supercomputer was as like your Cray XP. So this is actually first fact, right? And this supercomputer was made by CDAC Pune. Okay, in 1991, within 4 years actually we got this supercomputer, and it was made by CDAC Pune, right? So this is actually interesting fact. The fact is that when we are denied access to some technology, then India has the capability to make its own technology, right? So this is actually is basically kind of a very good, I think, achievement that we should be feeling proud of. Okay. Then you should also know that, see, all over the world, many countries actually are building their supercomputers. Okay. India is also among these countries. But of course, many other countries actually are building those supercomputers. But still, actually, you will see there is a kind of a ranking of these supercomputers. So the question comes, how do we do these rankings? Is there any particular way that you actually do this ranking? Because see, ultimately, India can come up with its own ranking mechanism. USA can come up with its own ranking mechanism. And the other country can actually also come up with their own ranking mechanism. The issue is what? Issue is basically, in a computer system, there are so many parameters. on which you can rank a supercomputer. You can rank a computer, let's say, right? You can rank a computer in terms of your latency. You can rank a computer in terms of, let us say, your energy consumption, right? You can rank a computer in terms of, let us say, throughput. So there are many parameters on which you can rank a computer, right? So how do we rank all these supercomputers in the world? So the way actually is basically using a set of benchmark, which are basically the standardized benchmark. So world has accepted those benchmarks for ranking supercomputer, and of course it should be transparent as well. It shouldn't be like I say, okay, fine, I ran this benchmark on my computer and I achieved this particular performance. That is not enough. I need to give the evidences, right? And the other countries should be able to reproduce those results. Then only that rank will be accepted. Fine. So there is a benchmark which was given by USA and Germany, right? There is a researcher in USA and there is a researcher in Germany, right? That three people actually who gave this benchmark, and till now, the time it was given till this point in time, that's the benchmark that actually is being used. And some of you, maybe from the mathematical background, right? So you will be happy to know that one of the benchmark problem is your linear programming problem. Right? It's a LinPack solution, LinPack software. It's a dense matrix, and then you want to solve these variables, basically. You want to solve your variable linear equation, basically. You know you have done that actually in your school time. But of course, the system problem is large enough to give you the challenge how fast you can compute it. Okay? Other than this linear programming, there are other problems like for energy, there are problems for graph processing, right? And some other dense data computation. So this is a kind of a collection of softwares that you need to run on your computer and then show your result. And where do you show your result? There are a couple of conferences which actually happen every year in the world. One of the conferences is Supercomputing, right? Another conference actually is also in the same domain. And you need to show your records there. And then other people actually accept it, then only we say, okay, fine, your results are good enough, and that's your rank. Fine? So even now, today, India's supercomputer is among top 100 supercomputers. And there was one time actually when we were actually 4th or 5th in terms of the ranking. So there was a computer which was developed by one subsidiary of Tata, which is Tata CRL, right? It's a computer which actually came from the industry, right? And it actually ranked at fourth supercomputer. Fine. So this is basically ranking. How do you do the ranking of supercomputers? And we should be feeling proud that we are still actually in top 100. This is actually a big achievement. But is it simply a technology race? Are we actually building these supercomputers only for the sake of coming in the top rank? It is not. There is a high utility of this particular technology, right? And that's why Government of India has spent crores of rupees. Even now, Government of India has a project of 10,000 crore rupees, which is National Supercomputing Mission, right? Where they want us to develop supercomputers and deploy them for different purposes, different usages, right? So if you just see the usages, right? What are the different usages actually which you can have from supercomputer? So one good application for supercomputing is weather modeling, weather forecasting, right? You will know that like maybe 15 years back, right? Professor Lalit will know, right? There used to be a broad DD news, right? Where you basically used to know, okay, fine. What will be the weather today or maybe in the week, right? But we were dependent on USA at that time. But now, we actually have our own supercomputers doing this weather forecasting. And how again this weather forecasting is done? There is again a partial differential equation. The model actually is based on PDEs, mathematics again, right? Which actually is used to do the weather forecasting. And of course, in weather forecasting, if you just see the models, it is going to take Earth's surface, it is going to take your air, right? Your fluid velocity, right? Basically modeling is going to be fluid modeling is going to be there, right? And many other actually systems actually which will be interacting with it. So you have a three-dimensional kind of a volume, right? The three-dimensional volume, then you have time, then you have your space, right? All of these dimensions make this particular problem of weather forecasting very, very complex. You have lot of sensors using which you get the data, and then you need to basically churn out this data. You need to process this data, not one iteration, multiple iterations. You need to do the simulation, right? And then find out, okay, fine. After maybe thousands of iterations, you get a prediction. What I want to tell you is basically, first of all, this weather prediction is very compute intensive task, which actually requires a lot of data. And this kind of data processing is not possible without using these supercomputers. See, I come from the big data technology. So there is another paradigm of computing where you believe in using commodity machines. You have thousands of laptops or commodity machines which are talking to each other, and then you are doing your processing. But let me tell you, that kind of architecture, that kind of framework of big data technology wouldn't work for the problem like your weather forecasting. Because your problem is compute intensive. Even for this partial differential equation, you have many systems which are interacting with each other. It's a tightly coupled problem, right? So that's why you need supercomputers. And the power of supercomputer is going to decide for how much duration you can do the forecasting, right? And how accurately you can do the forecasting. Okay? That actually should be clear to everybody. Why do we need supercomputers? So weather forecasting is one of the applications, right? But of course, there are other applications which are simulation-based applications. So what do you know by simulation? Why do we need simulations? So basically, simulation actually is going to be the alternative for doing the thing practically, right? So there are two alternatives. Either you do the thing practically, or you do simulations first and then find out, okay, which model actually or which policy is going to work. So if you do the things practically every time, it's going to be very cost intensive. Think about any surgery that you are doing on a human, right? And what actually you should do as a kind of a surgery. If you do the simulation first and then get confidence, or you get confident in yourself, oh, actually this is how I should operate this surgery, right? It is going to be the lesser chances of actually having some failures there. And believe me, the doctors, the surgeons actually who do critical surgeries, they spend hours and hours only to find out, only to see, okay, fine, how should I do this major or critical surgery, right? That's where actually the difference comes. And these simulations actually are cost-effective ways to know how do I do it. And the simulations actually are not only for the surgeries. There are many applications, even let's say scientific study, right? You want to study hydrogens or protons, right? There you have lot of data being generated and you want to basically process it from different aspects, different angles, right? Different viewpoint. And this is going to be possible only through simulation. Even a simple application of installing ATMs, let us say in a city. How many ATMs should I install at a particular location? It is going to ask you to do some simulation. Simulations of how many customers actually are going to reach on an ATM. What is going to basically know what is the average length of my queue on an ATM if I actually install only one ATM. What will happen if I actually have two ATMs? What will happen actually if there is a failure of an ATM? You have to see different aspects. And simulation actually is the way to find out final implementation that actually you want to do. Everybody with me till now, right? So what we have seen, okay, how did we get our first supercomputer? And there is a ranking mechanism. We also saw the usage of supercomputing, right, or supercomputers. Like, for example, we saw weather forecasting and then the simulations, scientific simulations. And even actually, you see the current warfare, as Professor Yudhvir was telling, right? This is basically asking us to use these supercomputing technologies again, right? Where if you, let's say, have a missile going toward the enemy side, right? You want to see, Okay, fine, what will happen as with the actions of the enemy? Enemy can actually jam my communication of my missiles. If I am firing, let's say, thousands of missiles or thousands of drones, what is going to happen if they jam some of the drones? They can't communicate with each other. They can't communicate with the machine actually with which I am controlling that. Right? Whether my target is changed, target position is changed, whether some of the drones actually has gone away. All of that actually need to be taken care of. Again, the simulation. And not only simulation actually. Simulation is one thing, but actually it's a real-time control. You want to process all of this sensor data of thousands of drones which actually you have sent to your enemy's side, right? And you want to control them in real time. You have to process the data in real time. So when you want to process this data in real time, basically you want to have a low latency. Low latency is the crux. Scalable computing is the crux, right? Low energy consumption is the crux. They are the parameters that actually you want to have when you are designing a supercomputer. Okay? So now, the question that actually I asked myself, so I have worked in big data technology, or I have used the laptops or desktop machines. How is a supercomputer different from a laptop? Right? So the first answer that I got was, okay, see, the supercomputer is basically 1 million times faster than your laptop. But how? What is the architectural difference of a supercomputer with a laptop? Right? So what I found that, first of all, in a supercomputer, as compared to your laptop, you have thousands of CPUs. It's basically kind of a cluster of mini nodes. It's again a cluster of mini nodes. And the focus is on fast computation, not on clock speed. So we have already got to the limit of our clock speed, how fast a processor can run. It is basically now cluster of processors, how can I use them effectively to do my computation as fast as possible. And there actually comes the metric which is called number of floating point operations. How many floating point operations I can do in a second. So currently, if you just see the fastest computer of USA, it basically processes, it can process around 1.2 exaflops operations in 1 second. So this exaflop is basically 10 power 18. And the fastest computer that India has around 540 petaflops, right? So basically, there's a huge gap. We are still in top 100, but actually we are still far away from there. So exaflops is basically not the clock speed, it is basically the number of operations that you can do per second. So this is actually one metric. Other thing that I see as an architectural difference, as I told you, like it's actually number of cores that you have, and each core actually can run multiple threads, multiple processing, right? It can do multi-processing, as like our single laptop. So you have actually kind of a hybrid kind of communication between the threads and the processes. When you talk about the threads communication with each other, it is going to be like I am running a process on a single computer, and there's a shared memory, and in the shared memory, these threads actually are communicating with each other. Okay? But once actually it comes to the communication of processes, this is going to be inter-process communication. So there are multiple interfaces. Let me tell you about, like, there is a message passing interface, there is a OpenMI interface, and there is a CUDA interface. You might have heard of GPUs now, right? Everybody actually is running AI workload and all that. So this kind of message passing or communication interface differentiate a supercomputer from a laptop. In laptop, normally the communication is going to be basically OpenMI, right? If you have CUDA also, now laptops actually have GPUs also, 1 or 2 GPUs, then you're going to have CUDA interface as well, or CUDA message passing interface as well. So you have millions of cores in a supercomputer. Million is basically 10 lakh, right? So you have around 10 lakh, even more than that actually as a number of cores in a supercomputer. Each of the core is going to have several GPUs, right? And then they actually are used to process your task where they would require the communication, and the communication is going to be through these different interfaces. Okay, you may not know the technical details, but actually you should know, okay, fine, there is going to be process-to-process communication, and a process will also have multiple threads which are going to communicate with each other. right? And CUDA is another way where I am delegating the task to some other devices and they are basically doing the processing for me, and then I have a mechanism of communication between CPU and the GPU devices. So this is the processing part. But actually, what we see that in a supercomputer kind of technology, the bottleneck is not the computation. The bottleneck is basically this communication again. You need a interconnect so that these devices can communicate at a higher bandwidth. So we have, like, for example, bandwidth like infi band, which is actually going to give you peta bits, actually kind of peta bits per second. That's a bandwidth that you have, right? And there actually the bottleneck. Believe me, even in big data technologies, bottleneck is not the cores or CPUs, right? Bottleneck is basically the communication. If you want to, let's say, transfer 1 gigabyte data, or maybe I should say 1 terabyte data now, the best way to send or transmit 1 terabyte data is basically store your data in a hard disk and then transmit this hard disk by courier, not by network. But network is going to be more costlier and more time-taking task. Okay? So this is basically kind of a supercomputing architecture, where you have multiple cores and GPUs, you have different message passing interface, shared memory versus non-shared memory. It is not like your CPU where you have uniform memory access. It is basically non-uniform memory access. And that is going to ask you to basically further optimize your processes or algorithms. Then comes your disk IOs. Disk IO is basically whenever you do any computation, you need to bring your data into main memory. But bringing the data from disk to main memory is again a costly operation. Again a difference of 1000 times. Right? So can I do something to actually achieve better performance? And there comes the use of parallel distributed file systems. Parallel file systems. Right? So these parallel file systems, basically all the CPUs and the cores and GPUs actually are kind of talking to the disk, which is of petabytes, right? Where you are getting the data from into the main memory, and then you are doing your iterations. For example, all the AI models, like your natural language processing model, they actually, ChatGPT again, right? These kind of models which actually have billions of parameters which you need to tune so that they can generate accurate answers, right? They are going to ask you to, first of all, have a good computation, right? And of course, you want to do your convergence as fast as possible, where the role of machine learning algorithm will come. So even now, so we have like one of the, like 2020, actually there is an initiative again from Government of India, where Government of India wants to have a supercomputer where it is going to be used for having natural language processing models for Indian languages, right? It is going to have, of course, other tasks, whatever we want to have, but going to focus only on AI and ML. Actually, and this is being done by one of my good friend at IIT Bombay, Ganesh. He actually is a project leader of that particular problem, the task, right? And again, there are some IITs and triple IITs fellows actually who are involved into that task, where you want to have a supercomputer specifically designed for AI ML kind of workload. Remember, what actually I'm trying to say, even these technologies like supercomputer is not like basically you make a supercomputer which will be used for all the tasks. No. You are basically kind of doing the customization for your particular task, right? So kind of computation that you require, how many disk IOs you require, how much communication you would require. Can I do something at the algorithm level? Should I need to do something at the architecture level? All of these questions need to be answered whenever you are customizing a particular technology to solve a problem. Okay? So we actually have now a supercomputer, I told you, which is basically comes actually in top actually 100, right? As I told you, and 540 actually is the 540 petaflops. That's actually is the thing that actually we have. And the computer that I'm talking about, this is basically called Param Siddhi AI. The computer name is Param Siddhi AI, right? And there again, India is basically kind of taking initiative in terms of, first of all, this interconnect communication channel. How do we communicate? right? So there actually also the cores, the CPU architecture. So we are basically planning to have Rudra kind of architecture for the processing, right? And the Sanchar is the name of your communication channel, right? So these kind of initiatives are being taken. So I would say that there is one aspect where actually we got the technology when we were denied the access, and we actually did very well. Not only in terms of having the technology, but also using the same technology for solving tasks which actually are very relevant for us. Even for agriculture, it's actually multi-billion-dollar industry. You're doing weather forecasting, and that kind of thing actually can be used for your agriculture. Precision agriculture, what to actually sow, when to actually reap it, right? All of these decisions can be taken using supercomputing technology. Cyclone prediction actually is another thing, right? This can be done using supercomputers, right? Drones, defense, right? Many different applications that actually are possible with the use of supercomputer, and we should be actually feeling happy and should be feeling proud that actually India has its own technology, right? So with this, I would like to conclude. Unless you have specific questions, I will be happy to answer those questions. Thank you.
That fellow has not seen what is 3-tier architecture. So next we are going to discuss correlation between supercomputing, data mining and AI applications. How they are correlated. How this picture comes, how these applications are taking place, and these are using data mining also, AI based applications also, and supercomputing also. So next is design of AI tools, how AI tools are designed, like their architecture, and practice on some few simple AI based tools we will work on now. Next slide. Supercomputing. Computing, actually what is computing? We have to do calculations. So if we take the example, in the starting there was a calculator. After that tab came laptop, single core system, dual core system. So concept will be clear from the single core and dual core. What was the difference between single core and dual core? Dual core was able to process double data. So efficiency of data processing increased. So supercomputing used the concept of increasing core to multiple times. From two dual core, we went for more cores. We kept on increasing the core of a computer. Means that give him a processing speed. So from which he was able to, system was able to process more data. Then is multi-core system. That is a supercomputer. Multi-core means there are more than more cores than the available in what we are using nowadays. That is a supercomputer. Next slide. Example we will take. One machine can do a work in 10 days. 10 machine can do a work in 1 day. Same way in the computer, if we increase the core, if we add 10 core, means that will process 10 times more data. That is the concept. So nowadays we are able to increase cores up to 5 lakh, 10 lakh. That is happening. We might not have seen, but this is happening normally. Google, okay. पीछे करने का. In supercomputer, we increase cores of machine to 5 lakh and more times, which process data at a very high speed. As data processing speed increases multiple times. Next slide. So this is the example of a supercomputer. Means multiple processor along with data processing. दिखाना photo. This is the picture of a supercomputer. Lot of processor and machines are combined together, and that is a setup. It may take large space. So that such speed give such machines give very high processing capacity. Next. supercomputer and supercomputing system. Supercomputer is a computer with all hardware located at one place, location with multiple cores as per requirement. Supercomputer और डिस्ट्रीब्यूटेड ऑपरेटिंग सिस्टम के बीच में आपको एक मैं कंसेप्ट समझाता हूँ. डिस्ट्रीब्यूटिंग ऑपरेटिंग सिस्टम जैसे गूगल है, वो नियरली 2.5 मिलियन सर्वर यूज़ कर रहा है आज की डेट में. गूगल जो हम वर्ल्ड वाइड यूज़ कर रहे हैं उसमें नियरली 2.5 मिलियन सर्वर्स हैं, लेकिन वो सुपर कंप्यूटर नहीं है. दैट इज़ यूजिंग द कंसेप्ट ऑफ सुपर कंप्यूटिंग, बट इट इज़ ए डिस्ट्रीब्यूटेड ऑपरेटिंग सिस्टम. Because in supercomputer all the hardware will be located at one place, but in case of distributed operating system multiple sites will be chosen and hardware will be located at more than one location. There are two ways to get supercomputing. Number one is increase core of a single computer. The diagram I have shown of a supercomputer, one is increase hardware at one location. Second is distributed operating system with hardware at multiple sites. Distributed operating system with hardware at multiple sites. I gave an example of Google. 2.5 million servers are available across the world. So that is a multi-site distributed operating system, but it is using a concept of supercomputing because data is coming from all over the world. Next. Nowadays, all international applications like WhatsApp, Facebook, Instagram, Twitter, AI applications are three-tier architecture. Okay, before going into three-tier, I will give you one example. C language, most of us have worked on. What is like you will see that on C language, everything giving input, writing code, and taking output, that was happening on the one screen. That was happening at the one screen. There was no database, there was no front end, there was not a middle layer. So nowadays, after that the languages concept came. I tell you one thing. सी लैंग्वेज का एग्जांपल हमने लिया, उसके बाद क्या हुआ कि इन्होंने रिकॉग्नाइज किया कि सी लैंग्वेज में फाइल सिस्टम था. फाइल सिस्टम इतना सक्सेसफुल नहीं था. उसमें मेरा एक एग्जांपल मैं बताता हूँ. मैंने एक फाइल को रन किया सी लैंग्वेज में, कुछ देर के बाद उसको दोबारा से रन किया तो वो आउटपुट नहीं दे रही थी. मैंने प्रोग्राम में कोई भी एडिटिंग नहीं की. तो डेटा मैनेजमेंट इन लैंग्वेजेस के अंदर बड़ा बैड क्वालिटी का इनमें इश्यूज रहते थे. और इसी तरीके से फ्रंट एंड का एग्जांपल लेके चलते हैं. कोई भी बंदा फेसबुक सीखने नहीं जाता. किसी ने देखा है कि कोई फेसबुक की ट्रेनिंग ले रहा है, ऑटोमेटिकली आप समझ जाते हो कि ये करने से ये होगा. दिस इज एग्जांपल ऑफ बेस्ट फ्रंट एंड. फ्रंट एंड मीन्स व्हाट यूजर इज यूजिंग, दैट शुड बी ऑफ बेस्ट क्वालिटी. डेटाबेस मीन्स आई गेव एग्जांपल, सी लैंग्वेज में जो फाइल सिस्टम था वो बड़ा इश्यूज के साथ था. तो सॉफ्टवेयर इंडस्ट्री ने क्या रिकॉग्नाइज किया कि हमारे पास डेटाबेस अच्छी क्वालिटी का होना चाहिए. तो फिर ये ओरेकल वगैरह जो थे, ये साथ में सभी जो उसके बाद में लैंग्वेजेस आई उनमें डेटाबेस को इंटीग्रेट किया गया. फिर कंसेप्ट आया डेटा माइनिंग का. डेटा माइनिंग क्या हुआ, बहुत सारा डेटा हमने इकट्ठा करना शुरू किया. उसके बाद सोचा कि उस डेटा में से अच्छे अच्छे कंक्लूजन निकाले जाएं. लेकिन क्या हुआ कि कंक्लूजन निकालने के लिए आपको सॉफ्टवेयर्स प्रोग्राम्स चाहिए. वो क्या है, फिर वो जाके जो सॉफ्टवेयर्स प्रोग्राम्स और जो प्रोसेसिंग कैपेसिटी थी उस डेटा को, वो जाके मिडल लेयर बनी. वो सुपर कंप्यूटिंग के लिए उन्होंने हार्डवेयर को इंक्रीज़ करना शुरू किया और प्रोसेसिंग कैपेसिटी है वो इंक्रीज़ करनी शुरू की. तो मिडल लेयर तब आई थी जब फर्स्ट हमारे पास फ्रंट व्यू के लिए मतलब नीड हमारे में जनरेट हुई, सेकंड टाइम पे डेटा के लिए, थर्ड में मिडिल लेयर के लिए. तो अब जो एप्लीकेशन डेवलप हो रही हैं वो सारी की सारी ये जैसे AI बेस्ड गूगल है आपका, ये सारी की सारी थ्री टायर आर्किटेक्चर. गूगल आपको यूज़ करने के लिए क्या देता है, एक छोटा सा ब्लैंक स्पेस देता है, उसमें आप कुछ भी लिखो वो आपका काम करके आपको रिटर्न करेगा. तो बेस्ट यूज़र इंटरफेस इससे अच्छा क्या होगा कि आपको सिर्फ कुछ कीवर्ड्स टाइप करने हैं और वो आपको सब कुछ सर्च करके दे रहा है. आपको कहीं पे कोई इंटरेक्शन नहीं करनी. ठीक है. डेटाबेस जहाँ तक बात है उसमें 2.5 मिलियन सर्वर्स हैं. मिडिल लेयर की बात है, उन सर्वर्स के लिए ऑपरेटिंग सिस्टम बनाए गए हैं, प्रोग्राम्स बनाए गए हैं, सर्च इंजन को मैनेज करने वाले सारे सॉफ्टवेयर्स हैं, वो आपकी मिडिल लेयर है। ठीक है, अब जो कंसेप्ट है ये सुपर कंप्यूटिंग का कंसेप्ट यही है कि इतने सारे सर्वर्स के लिए ऑपरेटिंग सिस्टम बनाना, उनको मैनेज करना, ये सुपर कंप्यूटिंग की कैपेसिटी को यूज करता है। चलो ये मैं बता चुका हूं। कोरिलेशन बिटवीन सुपर कंप्यूटिंग, डेटा माइनिंग एंड एआई बेस्ड एप्लीकेशन। सुपर कंप्यूटिंग क्या है? लार्ज डेटा को प्रोसेस करने के लिए, और थर्ड लेयर जो है ह्यूज डेटा, डेटा की रिक्वायरमेंट है, ह्यूज डेटा हमें चाहिए, और फ्रंट एंड हमें इजी टू यूज फ्रंट एंड चाहिए। तो इनमें कोरिलेशन क्या है? डेटा भी आ रहा है इसमें, फ्रंट एंड भी आ रहा है, प्रोग्रामिंग लेयर भी आ रहा है। माइनिंग मीन्स सुपर कंप्यूटिंग ऑपरेशन जो हैं वो माइनिंग का काम कर रहे हैं डेटा के ऊपर, और एआई बेस्ड एप्लीकेशन अभी जो भी आ रही हैं उन तीनों एंड को यूज करके बन रही हैं अब। ठीक है, ऑल टूल्स गूगल, फेसबुक, ट्विटर, इंस्टाग्राम यूज 3 tier आर्किटेक्चर एंड नीड सुपर कंप्यूटिंग पावर, लार्ज डेटा, फ्रेंडली यूजर इंटरफेस। नेक्स्ट, design of AI tools and application use 3 tier architecture. I have explained the 3 tier architecture. Then includes large database, third tier is large database, and use data of all web servers available across websites worldwide. वेब सर्वर क्या हुआ कि 2005 में जैसे इंडिया में आरटीआई आई थी, इसी तरह वर्ल्ड वाइड जो रिवॉल्यूशन था उसमें क्या था, सभी ऑर्गेनाइजेशंस के लिए कंपलसरी कर दिया गया कि दे विल हैव ए रजिस्टर्ड वेबसाइट, they will have a registered website and it will contain all legal data of their organization. तो थ्रू आउट वर्ल्ड इसमें डेटा वेबसाइट्स के ऊपर आना शुरू हुआ, वेब सर्वर्स का काम बढ़ा, वेब सर्वर्स में डेटा आया और इन सर्च इंजन्स ने उस डेटा को सर्च करके आपको आपकी क्यूरीज को हैंडल करना शुरू किया। ठीक है, हैव वेरी इजी टू यूज यूजर इंटरफेस, फर्स्ट टायर, नो नीड ऑफ हार्ड ट्रेनिंग इन ऑपरेटिंग इन एआई टूल्स एंड एआई बेस्ड एप्लीकेशंस, कोई ट्रेनिंग की जरूरत नहीं पड़ती, सब इजीली सीख जाते हैं। यूज मल्टीपल लेयर मिडिल लेयर विद सुपर कंप्यूटिंग कैपेबिलिटी टू प्रोसेस लार्ज डेटा एंड एल्गोरिथम टू हैंडल दिस प्रोसेसिंग, वो मैं आपसे डिस्कस कर चुका हूँ। नेक्स्ट स्लाइड, एग्जाम्पल ऑफ एआई टूल, चैट जीपीटी का हम लेते हैं। इन्होंने जितने भी वर्ल्ड वाइड, ओके, इसमें एक मैं एग्जांपल बता देता हूँ, प्रॉम्प्ट इंजीनियरिंग क्या होता है। प्रॉम्प्ट इंजीनियरिंग क्या होता है, नंबर वन देर प्रॉम्प्ट इंजीनियरिंग में दो एग्जांपल हैं, वीक प्रॉम्प्ट एंड स्ट्रॉन्ग प्रॉम्प्ट। आप चैट जीपीटी से सर्च करते हो तो उसमें वो थ्रू आउट जितने भी वर्ल्ड वाइड वेब सर्वर्स हैं वहाँ से डेटा पिक करके आपको रिप्लाई करेगा। अब उसके आगे आप जितनी बातें छुपाओगे वो उतना कम रिलेवेंट डेटा देगा और जितने क्लूज हम डालेंगे उन सब क्लूज के ऊपर वो डेटा प्रोसेस करके थ्रू आउट द वर्ल्ड जितने वेब सर्वर्स हैं उनसे डेटा को सर्च करके आपको रिप्लाई बैक करेगा। तो वीक प्रॉम्प्ट का क्या मतलब है कि आपने मान लो एक सिंपल लिखता है कि आई एम नीड ऑफ ए जॉब, एक तो उसने ये टाइप किया, दूसरे ने टाइप किया आई एम ए बीटेक ग्रेजुएट, दिस इज माई ब्रांच, दीज आर माई मार्क्स and I want a job in Delhi and the field should be like this। तो इस तरह से हम आप सर्च में जितने एलिमेंट्स डालेंगे वो उतना रिलेवेंट सर्च आपको करके देगा। तो वीक प्रॉम्प्ट का मतलब जरूरी इन्फॉर्मेशन आपने सर्च में नहीं डाली, स्ट्रॉन्ग प्रॉम्प्ट का मतलब जो रिलेवेंट कीवर्ड्स आप जिस पे डेटा चाहते थे या रिप्लाई चाहते थे वो आपने इंक्लूड किया है। ठीक है, वो स्ट्रॉन्ग प्रॉम्प्ट है। एक और पीछे करना, चलो नेक्स्ट, डिफरेंस बिटवीन गूगल एंड चैट जीपीटी। गूगल क्या है कि आपको मल्टीपल लिंक्स देता है और चैट जीपीटी क्या है कि आपको एक रिलेवेंट आंसर देगा, आपकी क्यूरी का सिंगल आंसर देगा। वो मतलब उसको इतना क्वालिटी का बना के देगा कि वो सिंगल रिप्लाई बैक करेगा, लेकिन गूगल में इट इज योर विजडम टू चूज ए आंसर। अब रिसर्च पेपर राइटिंग में हम चैट जीपीटी का यूज कैसे कर सकते हैं? जैसे एब्स्ट्रैक्ट है आप एक तो लिटरेचर, चलो रिसर्च पेपर बैक करना है, रिसर्च पेपर के मेन टॉपिक्स क्या क्या होते हैं? मान लो रिसर्च पेपर आप एक डिजाइन कर रहे हो, उसमें सबसे पहले एब्स्ट्रैक्ट रहता है, ठीक है। एब्स्ट्रैक्ट क्या होता है कि आपकी रिसर्च का जो जिस टॉपिक पे आप चैट जीपीटी से जो रिसर्च पेपर बनाना चाहते हो, रिसर्च पेपर दो तरह के होते हैं। नंबर वन रिव्यू पेपर, सेकंड इज डिजाइन बेस्ड पेपर। रिव्यू पेपर जो बनाना चाहते हैं वो चैट जीपीटी से इजीली बन जाता है, उसमें आपको बिना एफर्ट्स के आप रिव्यू पेपर बना सकते हो। रिव्यू पेपर में मान लो आपको एब्स्ट्रैक्ट डालना है, जिस टेक्नोलॉजी पे आप करना चाहते हो उसके रिगार्डिंग आप कीवर्ड्स डाल के, मान लो स्टेगनोग्राफी पे आप एक लिटरेचर रिव्यू करना चाहते हो, तो स्टेगनोग्राफी की जो टेक्निक है उसके बारे में इंट्रोडक्शन सर्च करना चाहते हो, उस पर कंटेंट सर्च करना चाहते हो, तो आप हो सकता है कि आपकी हो टेक्स्ट बेस्ड स्टेगनोग्राफी। टेक्स्ट बेस्ड के रिगार्डिंग रिलेवेंट हम डेटा सर्च करेंगे, वो एक रिप्लाई बैक करेगा। उसमें आप ये भी डाल सकते हो कि दिस शुड बी इन 250 वर्ड्स, तो वो आपका इंट्रोडक्शन पार्ट हो जाएगा। फिर लिटरेचर रिव्यू, उसमें आप क्या डालोगे कि वेरियस टेक्निक अवेलेबल इन स्टेगनोग्राफी एंड हिस्ट्री ऑफ स्टेगनोग्राफी। हिस्ट्री ऑफ स्टेगनोग्राफी में क्या होगा, अभी तक की जितनी भी रिसर्च उसने स्टेगनोग्राफी में हुई हैं उनको लिस्ट कर देगा। आप फिर उसमें सर्च कर सकते हो ऑल अवेलेबल टेक्निक इन स्टेगनोग्राफी विद नेम ऑफ रिसर्चर एंड ईयर ऑफ इन्वेंशन, तो वो डेट वाइज क्रोनोलॉजिकल ऑर्डर में आ जाएगी, ठीक है। फिर एनालिसिस में आप क्या डालोगे, सभी टेक्निक जितनी भी उसने सर्च की हैं, हर टेक्निक के प्रोज एंड कॉन्स आप डिस्कस करोगे, उन प्रोज एंड कॉन्स से आप टेबल बनाओगे। फिर उन सभी टेक्निक्स को डाल के आप एक 5 से 6 पेज की रिपोर्ट बनाओगे, जिसमें हर टेक्निक की मेरिट्स एंड डिमेरिट्स आप डिस्कस करोगे, ठीक है। ये करते हुए आप एक रिसर्च पेपर डिजाइन कर सकते हो, रिव्यू रिसर्च पेपर विद द हेल्प ऑफ चैट जीपीटी।